All your videos have like 5 views.
What's that?
All your videos have like 5
No,
views.
that they don't count on property. They don't. Yeah, when you see the number of views on there, it doesn't, because it's an educational site. It doesn't count on property. Those are views from outside of the of our. You guys all have accounts in my class, so it's different. It's different. Trust me, there's a lot more than that. I can see where the viewings come from. I guess track through Moodle, so I can see where they come from.
Can you see who views it?
I can.
Nice.
Yes, can. Okay, so let's take a look at some chapter 7 stuff. Has to do with radicals, and there's really just two things we do in chapter 7. We're going to solve some problems that you essentially already know how to solve. That I already went through in chapter 6, and then at the end we're going to learn how to solve equations that have square roots in them. And it's not hard. It's much easier than chapter 6 stuff. You'll see. But before we jump into that, let's just do a quick review of what it means to be like a square root or a cube root or something like that, right? So what is the square root of 9?
3.
It's 3. And it's 3 because what?
3 times 3.
Because 3 squared equals 9, right? Okay. What is the cube root of 8?
2.
It's 2 because 2 cubed equals 8, right? You get it?
Okay.
Okay. What is the fourth root of 81? Now, there's an easy way to take fourth roots, by the way. It's 3. How'd you get that?
Because 81 squared is 9 and 9 squared is...
Okay, yes, that's the trick. If you want to take a fourth root is really just a square root of a square root. Okay, and the reason for that is because, okay, this equals 3 because 3 to the 4th equals 81. But the same trick applies if I want to take a number to the 4th power. All I have to do is square the square, right? Properties of exponents tell us if I take a power to a power, I multiply the exponents. So 3 squared equals, 3 squared is 9. So 3 squared squared is 9 squared, which is 81, right? By the same token, fourth root of 81 is the square root of 81, right? Okay, so that stuff is all true. In general, we say that we would call each of these, if we want to describe them all at once, we would call these radicals, and the way we describe these is the nth root, where n is the index of the radical, aka it just tells you what kind of root are you taking. And a is what we call the base, or the argument. Okay, it's what's inside the radical. We can, if we want to, and there's good reason for doing this, I'll explain it in a second. We can write this as a fractional exponent also. We can write this as a to the 1 over n power. So if you ever see a number or a variable or any base taken to a fractional exponent where the top is 1 and the bottom is n, that's the same thing as taking the nth root. Okay? So how would I write, for example, how would I write the 5th root of 3 as a fractional exponent?
3 to the 1/5 power.
Yeah, right? Everybody see that? That's just 3 to the 1/5. If I write it as a fractional exponent. That's handy for many reasons, but one of them is that's an easy way to calculate radicals on a calculator. Calculators have a square root button, and some of them even have a cube root button, but very few have a 5th root button. There is a way to do that, but it's a little bit complicated. It's much easier. If I want to take a 5th root of 3 on a calculator, the easiest way to do it is just take 3 raised to the power 1/5, and your calculator will know what to do, right? Okay. The other good reason for that, for writing radicals as exponents, is because all of the properties of exponents that we've practiced all year, especially at the start of chapter 6, they apply. They apply to fractional exponents just like they apply to integer exponents. Let's put all the phones away, please. Oh, serious? Okay. fast, that's amazing. All right, so the fifth root of 3 is 3 to the 1/5. Okay, now we can go one step further with that too. Okay, we can say that if n is the index of that radical, and that's the bottom of the fraction always, right? That's the kind of root that it is. The bottom of the fraction is the index. Remember, you always associate that with the kind of root you're taking. What if I want to do something like this? What if I want to do something like the nth root of a to the m? You know, let's take an example. What if we want to do the cube root of 8 squared? Okay, in general, how do you suppose I could say this? How could I say the nth root of 8 to the m power as a fractional exponent? Now, the nth root of 8, we could write how? A to the 1 over n, right? So this just becomes a to the 1 over n to the m. What's our property of exponents for taking a power of a power?
It negates it.
What do you do if you take a power to a power? You multiply the exponents, don't you, right? So this is the same thing as a to the 1 over n times m, or m times 1 over n. What's that equal to? What is it? If I multiply m times 1 over n, what's that equal to? M over n, isn't it? Yeah, I just multiply straight across. So I can write it as a to the m over n power. Now, what do those mean again? Remember that the bottom of the fraction is the index of the radical, right? And the top is the power that we're taking it to, right? So then the cube root of 8 squared is what? Well, what's the cube root of 8?
2.
2 squared is what?
4.
Okay, another way of writing that would have just been 8 to the 2/3, right? Okay, let's practice this a little bit. Let's practice taking some radicals of numbers and taking numbers to rational powers like this. So we'll start with just some radicals. How about? What is the cube, what's the 4th root of 16?
16 to the 1.
Yeah, okay, what's the number?
2.
2. Square root of a square root, right? Okay. What is the cube root of negative 27?
Negative 3.
Negative 3. Okay. Why? Because negative 3 times negative 3 is 9 times another negative 3 is negative 27, right? Okay, so it's negative 3. Now that's important because one thing that tells us is we can take an odd root of a negative number, no problem, right? That was important to know. Okay, what is the 4th root of negative 16? I heard negative 2, is that right?
It's imaginary.
It's imaginary. We got a problem there. What's the problem?
You can't take
An even
it
number.
takes a negative and a positive. It's not to the right.
Okay, yeah, now think about this. Any number to the 4th power is going to come out to be what sign?
Positive.
Positive, right? A negative number to an even power is always positive, isn't it? Right? So that's not going to work. That's not surprising to us, though. That didn't work for square roots, did it? So this is, in Moodle, that's going to be the answer n for no real answer. Here's a way you can generalize this, right? All the stuff, we've already dealt with even roots a bunch because we've dealt with square roots. And a square root is simply the easiest example of an even root. But all of the issues and problems that we had to be aware of with square roots are going to extend to every even root. 4th root, 6th root, 100th root, you name it. If it's an even root, right, if it's an even number, and that the radical is an even number, the index of the radical, sorry, then you can't take that root of a negative number. We used to say, way at the beginning, we used to say you can't take a square root of a negative number, but what we really meant was you can't take any even root of a negative number, including a square root, right? So that doesn't work. Okay, how about, keep going with this. Let's see, how about, yeah, how about that? See if you can do that in your head. You can't. The answer is you can't. Break it into two parts. 4 to the 5 halves is the same as what? Say it again? 2 to the 5th, right? Because the bottom tells you what kind of root you're taking. So this is equivalent to a 4th root, or second root of 4. Second root's a square root, right? Square root of 4 is 2 to the 5th. What's that?
32.
32. Okay. What is 27, negative 27, how about, to the 4 thirds?
12, negative
No?
Nope.
I know what you did. Redo that.
12.
Let's see what you did. You made a mistake. See if you can catch it.
81.
81. Okay, now,
Oh,
see if we can do it. I know some of you guys maybe used a calculator. See if we can do it without a calculator. What kind of a root are we taking?
The cube root.
Cube root. So the first step is, what's a cube root of negative 27? Negative 3, right? So this stuff right here is going to give us negative 3 to the 4th. Well, what's negative 3 to the 4th? It's just negative 3 squared, right? Negative 3 squared is 9. 9 squared is 81. Okay, that's it. That's it. How about negative 16 to the 3 halves?
No,
Oh, we got problems. What's the problem?
because it's a positive, it's an even number.
Problem. Because we're trying to take an even root of a negative number. No go. That's not going to fly. That looks like this. If we broke this into steps, that'd be like saying, what is the square root of negative 16 cubed? But we can't get any farther than that. That's against the law, right, for real numbers. And we're not going to deal with i's anymore. We're only dealing with real numbers now. Thank God. Okay? Questions? All right. So let's move back here a little bit then. So how about to here? So the whole point of this first part of chapter 7 is so we can extend the trick from chapter 5 that we used to other powers of x. Now remember, just ignore the one on the left for a second. Let's look at this simple example on the right. Back in chapter 5, we could have made short work of this. This was the kind we liked. This was the easy kind. And why is that? How do we solve this?
You divide it by 2.
Isolate x.
Isolate x. Good. We can point to a single x, and so we can isolate it, right? By reversing order of operations. So what are the 2 steps we have to do?
Divide by 2 and the square root.
Okay, so first step, we divide by 2, and we get x squared equals 4. We're going to take a square root of both sides, right? And what's that give us?
2.
X equals
2 or positive.
not quite 2. What was it?
Plus or minus 2.
Plus or minus. Good. That's the key. Because that's an even, there's a 2 there, isn't there? Because that's an even, if we take an even root of both sides of an equation, we said we had to include a plus or minus. Okay? Now, don't confuse this with just a plain square root. What's the square root of 4?
2.
Just 2. It's not plus or minus 2. It's just 2, right? But if I solve the equation x squared equals 4 by square rooting both sides of the equation, then I have to include that plus or minus, right? It's a step that's included when you're solving for a variable, not when you're just taking a square root. Okay? Gotta have it though, because even root of both sides. Okay, let's do the one on the left. This is a chapter 7 problem. And you'll see that it's actually easier. It's actually an easier problem to do. What do we do over here? What are the 2 steps in order?
Divide by 2.
Divide by 2.
Root.
What do I do then?
Cube root.
Take a cube root of both sides. Okay, so we do a cube root. If I take a cube root of both sides of an equation here, what's that going to give me for my answer?
2.
2. Do I need a plus or minus?
No.
No, we don't. Odd roots are easy. Odd roots, there are no issues to worry about. Odd roots, you can put negative numbers inside them. Can't with even roots. When you take an odd root of both sides of an equation, you don't get a plus or minus, you just get an answer, right? And so they're much, much easier to work with. Issues, questions, make sense? Okay. How about, something like that? It's a little harder. You gotta solve for x there. What am I gonna do? Okay, we gotta be very careful to go in the right order here, don't we? Okay, and if you're having any issues about that, if you're not 100% sure what the first step is, write out the PEMDAS tree, and if we're isolating x, in which direction do we go? Bottom up. Good. We go backwards, right? So what's the first thing we have to look to do?
Subtract.
Add or subtract. In this case, subtract what? 3. First step is subtract 3, giving us x minus 4 to the 4th over 3 equals what?
27.
27. Okay, next rung on the ladder is what?
Multiply.
Multiply both sides by
3.
by 3, because I want to undo dividing by 3, right? So we multiply each side by 3, so those cancel. Okay, and we get, come on, phones away. Listener, if you're happy to be taking notes, but otherwise I want those away, or I'll be collecting them.
81. Or,
X minus 4 to the 4th equals 81. Good. What's next?
Exponents.
Okay, so what's that mean? We got to do exponents.
X to the 4th minus 4 to the 4th.
No, I can't do that. Can't do that. Remember, I don't have a property of exponents that says I can distribute if I'm adding or subtracting. But I don't want to, I'm trying to undo the exponent. How do I do that?
The cube root can go with 4.
Okay, I'm going to do a 4th root, right? Which is a square root of a square root, right? So I'm doing a 4th root of both sides. Good. So if I do a 4th root of both sides, I get x minus 4 equals what?
Plus or minus 3.
Plus or minus. Why the plus or minus?
Because it's an even number.
Yeah. Right, you get it?
Yeah.
Okay,
And then you
right?
add 4.
And then I add 4. So I'm really going to get 2 answers here, aren't I? Because I've got both positive 3, x minus 4 equals positive 3, or it equals negative 3. We can do the same trick, come on in. We can do the same trick that we did in chapter 5 with this stuff, right? We can just, if I want to isolate x, I have the option of just writing both my answers at once by adding the 4 in front of the plus or minus. And so you don't have to do it that way. You don't. You can do 2 separate equations if you want to. It's fine, but this is a little quicker. So x equals 4 plus or minus 3. If I take the plus, I get x equals what?
7.
7. If I take the minus, x equals 1. How would I check? Go back and see if it works, if I want to. 7 and 1, if I plug those in, I can see right away that if one works, the other works, can't I? Look at this. If I put 1 in there, 1 minus 4 is negative 3, but negative 3 to the 4th is
81.
81. If I put 7 in there, 7 minus 4 is positive 3. Positive 3 to the 4th,
81.
also 81. They do the same thing, don't they? Right? And if we look more closely, we'd see that they both work. Well, we can. Look. 81 over 3 is 27, plus 3 is 30, right? Check. They both work. Okay. Skip that. Let's do... Okay, let's do... Okay, how about that one?
Divide by -2.
Okay, divide by -2, right? So what's that give me?
X plus 3 to the 4th equals -16.
Okay, now what? Okay, 4th root of both sides?
It won't work.
It's not gonna work. How
Not
come?
gonna work.
It's
won't be there.
Oh my goodness.
Yeah.
Give me some. Yeah. Got some.
Okay, you can see now. Let me show you a trick here. Hey, now listen. Don't you guys really put the phone seriously? We got not much time to go here. I want to have absolute up here. Look up here, everybody. Focus. I'm going to show you a trick for this. We can go through. You could go through the steps if you want to. You could get x plus 3 equals plus or minus the 4th root of -16 and then realize, oh, problems. We got an even root of a negative number. That's fine. But you can see that right here that you're going to have that issue because think about this. Any number, regardless of what x is, any number that x ends up being, when I take x plus 3 to the 4th, what's the sign have to be? Positive, right? Any number to an even power is always not, it could be 0, I guess, but it can't be negative, can it? I can't take any number to an even power and get a negative result. So we can see right away that that's impossible. So the answer is n. Okay? You get that? Okay? Okay, last one. You can do this. You are so set. How about... Okay, how do I isolate x there, you suppose?
Subtract.
Okay, we're going to subtract 1. Good. Okay. Divide by 2. Okay, did everybody see that? Now look at this. If I want to isolate x, I'm going to take both sides to what power? 2/3, right? Everybody see that? Okay, if I take both sides to the 2/3, that's going to give me, these undo each other, right? So I get x equals, what's 8 to the 2/3? No. Cube root of 8 is what? 2. Squared is?
4.
Okay, now the question is, do I need a plus or minus?
No.
I don't. How come? Yeah, because the bottom is odd. So it's an odd root, which means no plus or minus. The answer is just 4. Everybody agree?
Awesome.
Okay, see how we're doing that?
Yes.
Okay, all right, get the idea. Okay. We jumped the gun on that one. I wanted to throw that last one at you a little bit. That's not till the end of the chapter. That's the last section in chapter 7, but you already are, I mean, you're kind of getting it. Yeah, do we have any time?
No, like 15. You got like 10 minutes.
There's not time. Okay, so a couple challenge problems. Challenge problems. Okay, good. So this is really 7.2, but I'm going to show you that a lot of 7.2, just to illustrate how easy chapter 7 is. You already know how to do this. How would I do that? If I'm multiplying 5 to the 4/3 times 5 to the 2/3, you just have to think. Now, don't get intimidated by the fact that the exponents are fractions. What does the rule of exponents say about multiplying like bases?
That if the bases are the same, they're basically,
What do you do? If you multiply like bases, you
you add
add the exponents. I keep the base the same, I just add the exponents, right? So this answer should be,
25.
no, not 25, just 5. Right, we keep the base the same because we know that a to the m times a to the n, remember, is just a to the m plus n, right? So the base stays the same. It's still 5, but I'm going to add the two exponents, 4/3 plus 2/3.
6/3.
Yeah, 6/3. So I get 5 to the 6/3. Well, what's 6/3?
2.
2.
So that's 25.
So 25 is my answer. Okay? Everybody get it? Okay, so what about, let's see, how about, okay, here's one. This is kind of a tricky one. So if I want to write this in its simplest form, this is one that you may or may not see right away. 4 to the 1/4 is the same thing as saying the 4th root of 4. And we haven't talked about simplifying radicals yet. But I don't want to get into that, launch into that too much today. But the same rules apply for other roots that apply for square roots. So for example, remember with square roots, if we had the square root of 50, how did that simplify?
The square root of
225
4.
square root of.
Okay, yeah, there's a perfect square factor of 50, right? We could write that as the square root of 25 times the square root of 2. And the square root of 25 is
5.
5. So we get 5 radical 2. So we have to do the same kind of stuff for other roots. Now clearly there's no number to the 4th that divides into 4. So it looks like maybe that's done. But here's the trick I want to show you. This is probably where we'll end up for today. Just kind of looking at this trick. What I always want to do here to simplify these things, the other trick I have, if I can write the base in terms of other smaller bases. In other words, if the base is a perfect square or a perfect cube or a perfect 4th, write it that way. Well, what is 4? What is 4 is a perfect what? It's a square, perfect square. So I could rewrite this as 2 squared to the 1/4, right? Okay, what is 2 squared to the 1/4 if I use my properties of exponents? If I take a power to a power, what do I do? No, what do you do if you multiply, take an exponent to an exponent? So if I take a to the m to the n, what do I get? Yeah, we multiply the exponents. A to the m times n. You know that. What if I have 2 cubed squared? I get 2 to the 6. Okay, the same rules apply for fractional exponents that apply for integer exponents, right? So this just becomes 2 to the 2 times 1/4 is 2/4, but what does 2/4 simplify to? So if I want to write it as a radical, it's just the square root of 2. Okay, see the trick? Okay, so the 4th root of 4 can be simplified to the square root of 2 that way. Okay? How about something like that? Those are not like bases, are they?
No.
If those were like bases, we could just add the exponents, but they're not, right? Okay, so what could we do? Well, one thing we could do here is we could use our last trick. We could write those in terms of smaller bases. 8 is a perfect what?
Square.
Not square.
Cube.
Perfect cube. 8 is what cube?
2.
Yeah, so we get 2 cubed to the 1/4. Now what about 64?
Yes.
8.
60, now, good. 64 is 8 squared, right? So if 64 is equal to 8 squared, 8 is 2 cubed, right? We just found that out. So 8 squared equals 2 cubed squared, right? Well, that's 2 to what power? The 6. Okay, so 64 reduces to 2 to the 6th to the 1/4, right? Now I've got like bases, don't I? They're 2's. So what is 2 cubed to the 1/4? So if I take a power to a power, what do I do?
You add the whole multiply like that.
Multiply exponents. So what's 3 times 1/4 is?
3/4?
Yeah. So I get 2 to the 3/4 times 2 to the 6 to the 1/4 is what?
3/10.
Okay, you're right. But I'm going to leave it as 6/4 because I want to multiply like bases and add. I'll have like common denominators, right? So let's leave it as 2 to the 6/4, right? And if I multiply like bases, I add the exponent. So I could write that as 2 to the 3/4 plus 6/4 is how many fourths?
9/4.
Yeah. So there's our answer. See? Okay. That's probably good for today. That's beyond 7-1 really stopped a little bit ago. I just wanted to get you started thinking about 7-2 a little bit. All right.
Oh, yeah. Like,